Hello, this is Mrs. Huntley. This is Module 4, Systems of Equations. You should be in your supplemental packet that has a front cover similar to what you're seeing here. And I would like you to please turn to the page that says Student Handout number 4 on the top left. It should be on or about page 17. And I would like you to add the essential question at the top. How do you solve a system of equations using substitution? So this is the second method that I'm going to teach you to solve systems of equations, to find the solution to the x and the y of two or more equations at the same time. So there is a list of fill-in-the-blank notes. So first thing that we're going to do is we're going to solve one of the equations for y if necessary. That's like putting it into slope-intercept form. We've been doing that for a while. So just using the term solving one of the equations for y might be something that's new for you, but I think I've been using it in class. We just have been saying put it in slope-intercept form. Sometimes they're going to be in slope-intercept form. Other times we're going to have to put one of the equations in slope-intercept form. So first the first thing we'll do is substitute the value for y in the second equation. And if you're like, wait, what? Don't worry. It will become more clear after I do a couple of examples. So then we're going to solve the new equation to find out what x equals. And once we know what x equals, we can substitute that back into the original equation to find the value for y. Finally, the last thing we're going to do is check our work to make sure we're correct. Okay, so right now you're probably thinking, I have no single clue what she's talking about. That's okay. Let's walk through a couple of examples together. I'll be doing all of the work, and I just need you to follow along with me. Make sure that you're listening and doing what I'm doing while I'm doing it, and then hopefully this will start to become more clear for you. So on the first example here, I've got two equations, y equals 3x and x plus y equals negative 32. So one of the equations is already solved for y. I'm already in slope-intercept form on the first equation, y equals 3x. So what I'm going to do is I'm going to take that 3x because I know y equals that, and I'm going to substitute it into the other equation for y. So I'm going to rewrite the second equation, x plus 3x equals negative 32. Why? Because y as in the question y, not y as in the variable y. I'm just going to show you up here because they're telling us that y equals 3x. So if y equals 3x, then I should be able to take that 3x and substitute it in for y in the other equation. Now, before winter break and a little bit after winter break, we were solving complex equations that only had one variable. So now I'm just going to go through and solve this equation for x because there's only one variable there, so I can figure out what x equals. So x plus 3x, that's going to be 4x, equals negative 32. Now to get the x by itself, I'm going to divide by 4, and whatever I do to the left side of the equation, I've got to do the same thing to the right side of the equation. So I know x is going to equal, let's see, negative 32 divided by 4 is going to be negative 8. So I'm halfway to my solution. I'm going to write my ordered pair up here, and I'm going to say x equals negative 8, and I've got to figure out what y equals. So now that I know that x equals negative 8, I can take that negative 8, I can take that value for x, and substitute it into the equation to solve for y. Now, I can substitute it into either equation. It doesn't matter if I pick the top one or the bottom one. They're both equal in that I can get the answer for y from either one of them. The top one, however, is going to be easier to solve. If I take x and take negative 8 and I substitute it in for the x in the top equation, so it's y equals 3 times negative 8, I can solve that in one step. If I had substituted it into the bottom equation, it would have taken 2 steps to solve it. Again, easy. I could do it. It doesn't matter. But since the top one already has y all by itself, it's just a matter of grabbing my calculator if I don't know it off the top of my head and multiplying 3 times negative 8. So 3 times negative 8 is negative 24. So I'm saying my x is negative 8 and my y is negative 24. Now I can use the other equation that hasn't been used yet, so this equation down here, for my check. So I need to take my x, -8, plus my y, -24, and see, does that equal -32? And again, I'm just going to grab my calculator, plug in -8 plus -24, and indeed, I get -32 equals -32. So I'm relatively sure I did all that work correctly. The next one is going to be very similar, okay? I have the top equation says y equals 9x minus 2, and the bottom equation says y equals 3x plus 10. Now, again, it doesn't matter whether I put parentheses around the top equation or the bottom equation. It's going to kind of work out to be the same. I'm going to take this whole quantity. I'm going to pretend like those parentheses are like hands picking up that blob of numbers, and I'm going to substitute them in for the y in that equation. So instead of writing y, I'm going to write 9x minus 2 equals 3x plus 10. Now, again, right before winter break, a little bit after winter break, we were solving equations like this. So I just need to do all of my steps in solving a complex equation. I go through the series of questions. There's no parentheses, but I do have variable terms on both sides of the equal sign. So I'm going to subtract 3x from both sides to get them all on the same side. Okay, so 9x minus 3x is going to be 6x. Everything else comes along for the ride, so minus 2 equals 10. Now I want that x term to be all by itself. So I'm going to add 2 to both sides of the equal sign. I have 6x equals 12. Divide both sides by 6. And I'm going to say x is going to equal 2. So I'm halfway to my solution. 2 is my x. Now I can take that 2, substitute it into either equation up here. I'm going to go around the long way just so I don't run into it. I'm just going to grab the top one because it's on top. And I'm going to say y equals 9. Instead of x, I'm going to say times 2 minus 2. So y equals 9 times 2 is 18 minus 2. 18 minus 2 is 16. So I'm going to say I've solved x is 2, and I just solved y is 16. So I'm going to take those values. I'm going to substitute in to the other equation to do the check down below. So instead of y, I'm going to say 16 equals 3 times 2 plus 10. Y times 2? Because I said x was equal to 2. So does 16 equal 3 times 2 is 6 plus 10? 16 equals 16. So yes, it works. If you grabbed your calculator at this point and you just said 3 times 2 plus 10, or if you did it in your head and you knew at that point that that was equal, that's fine. I just tend to show all of the steps so that somebody doesn't think that, like, where'd you get the 6 from? How'd that happen? So that's why I tend to show all the steps. Okay. Number 3 is probably the most complicated one that we've come up with so far. Again, it's not super bad. Just stick with me. We have one equation that's solved for y. So y equals -x plus 4. I'm going to put parentheses around this entire thing because that's what y equals. And I can pick up that entire thing and put it into this equation in place of the y. Now, what does that look like? I'm going to have 5x plus 6. Now, instead of y, I'm going to put my parentheses with what I said y equaled. -x plus 4, end parenthesis, and then the rest of the equation comes down, equals 13. So now, again, we just have a complex equation with one variable that we learned how to solve a long time ago. It does have parentheses, so I need to distribute to remove those parentheses. So I'll have 5x. 6 times -x is going to be -6x. 6 times 4 is going to be a positive 24 equals 13. I'm going to draw my line down. Combine like terms. 5x minus 6x is going to be -1x plus 24 equals 13. I need to subtract 24 from both sides. So -1x equals, let's see, 13 minus 24 is going to be a negative 11. Divide by negative 1, divide by negative 1, and x equals 11. So I'm halfway to my answer. X equals 11. Now I have to figure out what y equals. I'm going to plug in what x equals to the top equation. It's going to be easiest to solve that one because I already have y all by itself. So y equals negative 11 plus 4. If you're not great with integers, grab your calculator and plug in negative 11 plus 4. Negative 11 plus 4 is negative 7. So I'm going to say my y value should be negative 7. I'm going to take that x and y and I'm going to check it with that second equation here. This equation right here that I'm circling, I'm going to bring it down here and plug in my values for x and y and check my work. So 5, instead of x, I'm going to say times 11, plus 6, instead of y, I'm going to say negative 7. Does that equal, I just wrote that green is on there, 13. Okay, does that equal 13? So if you want, you can grab your calculator. I'm going to do the math in my head. So 5 times 11 is 55. Plus 6 times negative 7 is going to be a negative 42. So you could say 55 plus negative 42 or just 55 minus 42. 55 minus 42 is going to be 13, and 13 equals 13. So that works. I know this is a hard concept. Believe me, I know. And I know those of you that struggled with solving equations back in December and the early part of January, I told you it was coming back again. I asked you to come in and get help and make sure that you were passing that assessment because I knew that this was coming. And frankly, you're going to have to solve equations for probably the rest of your academic career. So if you are still struggling with solving equations, please, 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 please come in and get some extra help with it. I will work with you. Okay, let's do, let's see, I'm at 12 minutes. Let's do a couple more together, and I'm going to be asking you to be pausing the video and seeing what you can do on your own here. And actually, I wish they had given us a little bit more space to be working. So number 4, I have one equation that says negative 3x plus 4y equals 7, and the second equation says y equals 3x minus 5. So I already know that y equals this amount. So I'm going to pick up this whole blob of numbers. I'm going to take it and substitute it in this equation in place of the y. So I'm going to write the first part of that equation starts negative 3 times x plus 4, and I'm going to start with the parenthesis, 3x minus 5, end parenthesis, equals 7. I just took this equation that's up here and I substituted in what this says y is equal to in place of the y. What I would like you to do right now is pause the video, see if you can distribute that 4 to the parentheses, and then unpause the video, make sure you did the distribution correctly. 4 has to hit everything inside the equal sign, or inside the parentheses. So I'll have negative 3x. 4 times 3 is 12. Oops, that should be a plus 12. 4 times negative 5 is a negative 20 equals 7. Okay, so when I distribute it, I've got negative 3x plus 12x minus 20 equals 7. Now I can combine like terms. So please pause the video and make sure that you're able to combine like terms here. Nine x minus 20 equals 7. I should probably do that. I'm going to add 20 to both sides. 9x is left on my left, equals 27. Divide by 9, and x is going to equal 3. And again, I wish they had given us a little bit more work room here. So my x is 3. I need to figure out my y. Now, I know I kind of wrote a lot of stuff up here. I'm just going to erase that out so that you can see the equation and what I'm grabbing, because I'm grabbing this bottom equation, And the reason I'm grabbing the bottom equation is because it's already solved for y, and I just have to plug in my value for x. So y equals 3 times 3 minus 5. 3 times 3 is 9, minus 5. 9 minus 5 is 4. So I'm saying my y is equivalent to 4 here. Now I'm going to take that and substitute it in to the equation that hasn't been used yet to make sure to do my check. So negative 3, I said x was 3, so negative 3 times 3 plus 4 times 4, does that equal 7? Negative 3 times 3 is negative 9 plus 16, does that equal 7? And 7 equals 7, so it works. Okay, the next two are a little bit more difficult because neither one of them says what y equals or what x equals. So I have to pick one of the equations to put into slope-intercept form or solve for y before I can even start substituting. And they don't give us much work room here, so it makes it all the more difficult to actually show you what I'm doing because I just don't have enough space. So if you need to grab an extra sheet of paper, because I've got some room at the top of mine, but I'm looking at the workbook and you guys really don't have much room in the margin. But I'm going to just go at the top here and rewrite the equation negative 2x plus y equals negative 3. And this is the one that I'm going to solve for y. And the reason I picked this one is because the y does not have a coefficient in the top equation. In the bottom equation, negative 6x plus 4y equals 4, I would have to do 2 steps to get it into slope-intercept form. On the top equation, I just have to do 1 step. And hopefully you're recognizing that I'm just going to add 2x to both sides of my equation. And I'll end up with y equals 2x minus 3. So this 2x minus 3, this is what I'm going to take. I'm going to put parentheses around it, and this whole value is going to be substituted in the bottom equation for y. So I'm going to write negative 6x. Actually, I'm going to switch colors so that you don't think it's that last equation. So negative 6x plus 4 times the quantity 2x minus 3 equals 4. Again, just go through the steps of solving an equation. If there's parentheses, you've got to distribute to remove them. So I'm going to distribute. 4 times 2x is going to be 6x. I'm sorry, that's going to be 8x. Math in your head is usually a good thing, except when you start getting tired. 4 times 2 is 8, so it'll be 8x. 4 times negative 3 is negative 12. Is going to be equal to 4. Now I'm going to combine like terms. Negative 6x plus 8x is going to be 2x minus 12 equals 4. I want the x to be all by itself, so I'm going to add 12 to both sides. And 2x is going to equal 16. Divide by 2, and x equals 8. So I've got half of my answer. I know the x. I'm going to use that to solve for y. So I can use my transformed equation to solve for y. The only problem is if I made a mistake transforming it, I might still get a mistake. So actually what I guess I would recommend is going back to one of the original equations to solve for y. So I'm going to pick this top equation because I just used the bottom equation. So I'm going to say negative 2 instead of x times 8 plus y equals negative 3. Negative 2 times 8, it's going to be negative 16 plus y equals negative 3. I'm going to add 16 to both sides, and y is going to equal 13. So I'm going to take that 8 and the 13, again using the bottom equation, and just do a check to make sure that I've done everything right. And I'm kind of flying by the seat of my pants here because I have not done this one to begin with. So -6, hang on, let me find it because I've written all over it and I can't see my actual numbers anymore. So -6, this is my check. Instead of x, I'm going to say what I think x equals, which is 8, plus 4. Instead of y, I'm going to say 13, and see, does that equal 4? Gosh, I hope I did this right. -6 times 8 is -48. 4 times 13 is 52. Does it equal 4? -48 plus 52 does equal 4, and 4 equals 4. Whoop, whoop, I did it correctly. Okay, we are at 20 minutes, so I'm not going to finish this. We will finish this in class together tomorrow. Just know when you're substituting in, if one of your equations is already solved for y, you're putting parentheses around that whole value of whatever y equals. You're substituting into the other equation in place of the variable. Solve for x. Once you have the x, then you take that and put it back into the equation that wasn't used to solve for y, to solve for x, and then you check it in the first equation. Okay? We will be working on this together in class and next week. So if it is not clear at this point, don't panic. Hopefully it will be in the next couple of days. Have a good night. See you in class.